All right, now we're going to solve a trig equation that has that we need a trigonometric identity to help us solve it. So we saw something similar to that right here, where we used a trig identity to go from cosine squared to sine squared, but then we proceeded to solve it like we had been with factoring. Here we're going to use another trig identity. We're going to use the double angle identity, the 2 sine x cosine x. So if I multiply both sides by 2, I would have 2 sine x cosine x equals 1, okay? And 2 sine x cosine x, if you remember, that's the same thing as the sine of 2x. So we end up with the sine of 2x is equal to 2 times a half is 1. And then if you look at a unit circle again, we end up with, where is sine equal to 1? The only place sine is equal to 1 here is at pi over 2, okay? That's the biggest that it gets all the way around, okay? But the problem here is we end up with a 2x. So pi over 2 is the sine of pi over 2 is equal to 1 according to our unit circle. So that means that 2x has to be equal to pi over 2, okay? So I would say 2x is equal to pi over 2. And remember, if we went all the way around over and over and over again, I would keep hitting 1. So I'm taking that pi over 2 and I'm adding 2 pi over and over. If I divide by 2 now, what's going to happen is I'm going to end up with, our solution is x equals pi over 2 divided by 2 would be pi over 4. And then plus the period was 2 pi, but when I'm dividing by 2, I end up getting to these solutions quicker, okay, because I'm doubling the input, so I'm getting to the solutions faster. So what does that mean? Why is that important? Well, because pi over 4 is just going to be a solution to this thing. But so will pi over 4 plus pi, right? Adding pi one time, that's pi over 4 plus 4 pi over 4. Right, pi is the same thing as 4 pi over 4 to get a common denominator, and that's 5 pi over 4. And 5 pi over 4 is still within 0 to 2 pi. Okay, and just like we saw before in that previous video, I'm going to keep adding 4 pi over 4. If I add 4 pi over 4 again, I'd be at 9 pi over 4. Right, 2 pi is the same thing as 8 pi over 4. So as soon as I go beyond 8 pi over 4, I don't have to include that, but I do have to include the 5 pi over 4 solution. So there's my two solutions. X equals, within 0 to 2 pi, x is equal to pi over 4, and then 5 pi over 4. Okay, so I end up with more solutions because of the doubling that's going on right here. Okay, so it's sine of 2x is equal to 1. Pi over 2 works, so pi over 2 gives us 1, so that 2x has to be equal to pi over 2. And then because it's sine, the period is 2 pi. But because it's 2x, everything gets divided by 2. So our solutions are x equals, instead of pi over 2 plus 2 pi, it's pi over 4 plus 1 pi. And then because we're going around to 2 pi, we do get to add pi one time and get us a second solution. All right, again, always check. All right, so I got pi over 4, 5 pi over 4. I'm going to check with Desmos. There's my sine x cosine x y equals a half. Again, that was my equation, original equation before I doubled everything. And that's what you want to put in there. You always want to put in the original, so if you made any mistakes after the original, you can still check your solutions. Now notice, it's giving me decimals like I was talking about before. So I'm going to change this step size from pi over 6 to pi over 12. That's usually something that'll fix it. Not necessarily always, since I've already graphed these. Let me kind of copy and paste them again. All right, and let's do this. Yeah, y equals a half. And now let's see if it'll give me, it's still not giving me a whole number of solutions. You can type in something like pi over 4 by itself, and it'll give you that decimal that we're getting right here on the graph. 7.85. I don't know why it's not giving me the exact solutions. It should. Oh, there it goes. Okay, so pi over 4.5. Well, I thought it would give it to me. Alright, 5 pi over 4.5. I don't know why, if I barely move my mouse, it goes from a decimal approximation to exact. But anyway, there's the solutions that I was getting. Pi over 4.5, 5 pi over 4.5. So pi over 4, 5 pi over 4. That's where this thing is. That's where this thing is true. All right, in this problem I got sine x minus cosine x equal to 1. To solve this one, what I would do is I'm going to end up using the Pythagorean identity. All right, but what I would do is add cosine to both sides initially, and I'd have sine x equals 1 plus cosine x. All right, and then what I want to do at this point is square both sides. So I end up with sine squared x. And if I square the right side, I'm going to get this thing times itself. So if you can imagine it, it's 1 plus cosine times 1 plus cosine. I'm going to FOIL that. If you can FOIL that in your head, that's fine. I'm writing it out just so you can see where the numbers are coming from. So I'm going to get a 1 when I multiply there. Outside and inside is both a cosine, so that'll be a 2 cosine. And then the last thing will be a cosine squared x. Alright, now the right hand side, everything's cosine. I can get everything over here to be cosine using that trig identity that sine squared is just 1 minus cosine squared. Alright, and then I have 1 plus 2 cosine x plus cosine squared x. Okay. Last step, I'm going to add the cosine over. I'm going to subtract the 1 because I want to get this quadratic in cosine, so I want to get the cosine squareds grouped together. And if you look what we end up with, I end up with 0 on this side. And then this goes away, and I end up with 2 cosine x plus, this is 2 cosine squared x. And then I can pull out a 2 cosine from this guy, and I'm left with a 1 here, and then a cosine here. If I set each piece equal to 0, I end up with 2 cosine x equals 0, or I could get 1 plus cosine x is equal to 0. So this would be if 2 times cosine is equal to 0, that's the same as saying just plain old cosine is equal to 0. And this would be cosine is equal to negative 1. So again, go back to your unit circle. So cosine is the x-coordinates equal to 0 here and here. Alright, and then cosine is also, we're looking for where it's equal to negative 1, and that's over here. So where is cosine equal to 0 when x is pi over 2, or when x is 3 pi over 2? Where is cosine equal to negative 1 when x is equal to pi? Alright, now you may be thinking, alright, we're done, but you got to be careful. This is just like with rational equations. If you remember rational equations from pre-cal 1, if you square to solve, which we did right here, we squared from this step to this step. We squared both sides of the equation. Okay, and you have to be careful with that, because from that step on, things like, if I have a negative 1 and a positive 1, negative 1 squared is equal to positive 1 squared. 1 does equal 1. But before that, before I squared both sides, I would have had something like negative 1 equals positive 1. And that's not true. So when you take a step, when there's a step in your work where you square both sides, you could have things that aren't true that from that point on are true. And again, from that point on, eventually you're going to get to your solutions. So you have to check. If you ever square both sides of an equation to solve the equation, no matter what the equation type, you have to check your solutions. You have to check it back in the original. So pi over 2, 3 pi over 2, and pi, I'm going to start off with pi over 2, is the sine of pi over 2 minus the cosine of pi over 2. Is that equal to 1? Alright, this is, again, pi over 2, that's 90 degrees, so that's up here at the point 0, 1. So the sine of pi over 2, that's the y-coordinate, 1, minus the cosine is the x-coordinate, 0. Is that equal to 1? Yes. So pi over 2 is a solution. Okay. Another possible solution we get is 3 pi over 2. All right, 3 pi over 2 is the sine of 3 pi over 2 minus the cosine of 3 pi over 2. Is that equal to 1? All right, come over here and look at this. 3 pi over 2. 3 pi over 2 is down here. The sine is -1, the cosine is 0. So this would be -1 minus 0 is +1. That is not true. So 3 pi over 2 is not a solution to this thing. All right, and then finally let's look at at pi. So sine of pi minus the cosine of pi. Is that equal to 1? Now we're here at this point. The sine is 0 minus the cosine of pi is -1. And that is true. 0 minus -1 is 0 plus 1, which is 1. So pi does work. So this one works and this one works, but we did have one that's called an extraneous solution. That one did not work. We have to be very careful with those. All right, let's look on a graph. Sine x minus cosine x on the first line, 1, the right-hand side of the equation in the second line. And from 0 to 2 pi, there's my only two solutions right there, pi over 2 and right there at pi. So pi over 2 and pi is what we ended up with our solution. That 3 pi over 2, again, we saw with the graph, that was not, let's see, 3 pi over 2 would be right about there. 3 pi over 2, we're going down below. There's the line we need. We're not up here. Okay, so there's the only two solutions that we have for this one. All right, and then the very last equation type, we want approximations for these things because they're not going to be exact because we're getting these decimals. But again, the unit circle is going to help us think through how we're going to do this. So the very first thing you're going to do is arc trigonometric functions to solve these. So if I know tangent x equals this number, then the x, the value for x, I just take the arctangent of both sides. Arctangent of tangent would just be x. And then I would have the arctangent of the decimal over here, 12.8044. All right, so there's one number. All right, again, this is very important that you're in radian mode. There's one number, okay? Now again, using my unit circle and thinking about how arctangent works, remember arctangent can only put you in quadrant 1 or quadrant 4. It's going to put you in quadrant 1 if this number is positive, so it is. So that means we're in quadrant 1. All right, and arctangent is, you're basically saying what angle produces this slope. So a slope of 12, that's pretty steep. This is a slope of 1. This is a slope of square root of 3. So we're way up here somewhere. So remember, slope is talking about a line. So if I go from the origin to some point, we're saying the slope of that line is about 12.8, almost 13. Well, where else is that going to take place between 0 and 2 pi? It's going to take place any point that's collinear. If you're on the same line, it's the same slope. So down here in quadrant 3, I'm going to hit that same point again and have that same slope again. So how do I find what angle that is? Well, this is the angle that we were given before that the calculator produced. And if I add pi to that, pi radians, that's 180 degrees. That's going to give me to right here. This is a semicircle because it's a straight line. So that's 180 degrees or pi radians. So I just take my answer and add pi to it. And that's the second number. Okay, so I would take these two things and round them to 4 places. So there's my two answers. Okay, now again, it's just regular tangent. It's not tangent 2x or anything like that. So I don't have to worry about going beyond that. That's just going to be the 2, because the next time that I hit this line again that has that slope, the next time I would hit that would be this number plus another pi, and that would go beyond the 2 pi right there. Right? So there's my two solutions. Now with cosine, a little bit different. Let's think about how cosine works. For cosine, arc cosine is what we're going to use to solve it. Let me move this over here with this. Delete this for now. Arc cosine is a little bit different than arc tangent, arc sine. Arc cosine will put you in quadrant 1 and quadrant 2. All right, and so because it's negative, it's going to be quadrant 2. That's where all the x coordinates are negative. Okay, so we are going to be in quadrant 2. So I know we're in quadrant 2 now. The question then becomes, if the x coordinate is negative 0.4-ish, right? There's negative a half. So we're somewhere right in this region right here. So the x coordinate, I'm not going to the center now because I'm not talking about slope. I'm talking about x coordinates. So there's negative 0.5, so negative 0.43 is going to be a little bit to the right of that. So where else could I possibly have that same x coordinate? Well, just keep following through the x-axis and come out the other side, and we're going to be at some number that's a little bit beyond 4 pi over 3. So we're a little bit less than 2 pi over 3 now. So arc cosine is going to give me this angle right here. Right now it's going to give me the angle that gets me to that. Okay, now how do I find what angle this is down here? Right, from here all the way to here. What you see here, to get here, the same position down here, I'll rotate this same angle down. And if I rotate it down, that would be this same angle right here, just flipped over and rotated down like that. And then to get to that same position, but what we're wanting from here to here, I just add 2 pi to it. All right, so to summarize, it's the opposite of this angle, whatever arctangent gives us, and then plus 2 pi. So the easier way to think of it is, the first thing I'm going to do is x is the arc cosine of this number, negative 0.4317. And then whatever that gives me, I'm going to take that number and subtract it from 2 pi. And that'll give me my second angle. So I'm going to say arc cosine of negative 0.4317. All right, that's one number. And then let me just do this. 2 pi, 2 second pi minus that answer. And there's my other number. Alright, so that's my solutions that I'll stick in here and round those to 4 decimal places like we did with the tangent solutions just a second ago.